All right. Good evening, children.
Good evening,
ma'am.
Good evening. Now, first of all, I want you all to take screenshots of the contents of the last session. Okay, so I'll tell you what to do with the screenshots. Now, start. This is the first picture. Take a screenshot, or if your device is not able to capture a screenshot, then you can take a photo using a mobile phone. Can you all take
I
screenshots
took notes.
on your device?
No, ma'am. I
Yes,
took
ma'am.
notes on this last class, ma'am.
No, I didn't get that. Please come again.
No, ma'am. I have took notes on this last class.
You'll have to close.
No, ma'am. I have written as notes.
Oh, okay. So you've already taken notes.
Yes, ma'am.
Okay, fine. Okay, I'll leave it to you. Like, now you take the pictures now. You take the screenshots now. You can decide if you want to write them again, or if your notes are sufficient for you. You can decide on that. Yeah. Yes, children. Is this over?
Yes, ma'am. Taken.
Okay. This is the next one. Done, all of you?
Yes, ma'am. Done.
Okay. Next one. So, under Anintika's instruction, I included the distributive property also here. You mentioned, right, Anantika, yesterday that the distributive property is missing here, and I said it's in a separate slide. So I just put it in the same slide, so you can take it. Done, children?
Yes, ma'am. Done.
Okay, not all this. Not all this. Yeah, sum up this one. You need to check the boxes. Now, supposing, now how do you understand this? Closed under. So we are checking the closure property. Okay, so now rational numbers. Are rational numbers closed under addition? If yes, tick. Sure, tick there. If not, cross it. So this is how you understand, this table. So we are checking the closure property. Closure property for all these numbers, rational, integers, whole, and natural. And all the four operations: addition, subtraction, multiplication, and division. So now how do you read this? Are rational numbers closed under addition? If yes, next. Are rational numbers closed under subtraction? If no, this. Are rational numbers closed under multiplication? If yes, if no, like this.
Ma'am, we should do this as homework.
Yes. We have understood all this in yesterday's session, right?
Yes,
Yes. You need to fill up this as homework, correct?
ma'am.
Okay.
Ma'am.
Yeah. And the correct answers, I'll just wait for some 2-3 days, or maybe by the weekend, I'll share the images of the correct answers just for this table. Wherever I need to share the answers, the images of the solutions will be shared with you on WhatsApp. So you can just check. You can just check if you're wrong, and I'm sorry, if you're right, and if you're wrong, you can correct it. All right.
Yes, ma'am.
Good evening, ma'am. Sorry to disturb you.
Hi, is it Aishwarya's mother?
Yes, ma'am. She
Ah.
joined just now, ma'am, because we have some issues. So she joined just now, ma'am.
No problem.
Did she miss anything, ma'am?
No, nothing in today's session, ma'am. Last session, I have shared the recording with you.
Okay.
Please ask her to go through that. Yeah.
Sure, ma'am.
This session we just started. Actually, there was another child who had some issues with joining, so I just started.
Sure, ma'am. Thank you, ma'am.
Yeah. Hi, Aishwarya. Good evening.
Good evening, ma'am.
Aishwarya, you just wait in the call. You may not understand what we are doing now. I'll just tell from where you can catch up with us. All right?
Yes, ma'am.
Yeah. Yes, children. Is this done?
Yes, ma'am, done.
Aishwarya, you can just take the screenshots. I think I can tell you about them later. Yeah. Aishwarya,
Yes, ma'am.
yeah, take screenshots of these images. This is the first
Yes, ma'am.
one. Yeah.
1 second. Just a moment, ma'am.
Yeah.
Yeah, done.
Yeah. This is the next one.
Yes, ma'am.
Done?
Yes, ma'am. Done, ma'am.
Okay. Not this, not these. Just wait.
Yes, ma'am.
Oh, I think I came past that. Yeah, this one. This is the fourth one.
Yes, ma'am. I did it.
Sure?
Yes, ma'am.
Okay. Not these. Yeah, class, now you can continue. All of us can take from now. Yeah, this one. This is the next one.
Yes, ma'am.
So we need to check if rational numbers are commutative under addition. Rational numbers are commutative under subtraction, multiplication, division. Similarly, integers. Integers are integers commutative for addition, subtraction, multiplication, division, and so on.
Okay, ma'am.
So put a tick if yes, cross if no. All right, class?
Yes, ma'am, taken.
Okay. Not these, not these. Yeah, this is the next one. So like our whole numbers associative for addition, whole numbers associative for subtraction. If yes, tick. If no, cross.
Okay, ma'am.
Yeah.
Done,
Okay.
ma'am.
After the after
Yes, ma'am,
this,
done.
after this, please. This one. There's somebody at the door, children. Just a minute. I'll come back. Yeah, thank you, children. This is the next one. Done, children?
Yes, ma'am.
Done,
Okay.
ma'am.
All right. This is the next one.
Done, ma'am.
Okay.
Done, ma'am.
Yeah, this one next.
Done, ma'am.
Okay. This one next.
Done, ma'am.
Done, ma'am.
Okay. I think associativity is missing, right? Did I show you this slide, children?
Yes, ma'am.
Yes, ma'am, you did.
Okay, there should be one for associative, one for commutative, then closure. Closure, commutative, associative. Yeah, that's it.
Yes,
A table
ma'am.
like this for these three. All right, fine.
Yes, ma'am.
All right. So Aishwarya, you will have to watch the recording which I've shared with you. First, watch the recording and then complete the contents of the slides which you have taken today, meaning the screenshots which you have taken today.
Yes,
All
ma'am.
right. Yeah. So with the help of the recording, you will be able to complete these answers. The table which you have to fill, you will be able to complete them once you understand the contents of the video, the recording which I've shared. Yeah.
Okay, ma'am.
Yeah. So please watch the video first, the recording first, and then do the homework. So all this must be written out in a notebook. All students are requested to maintain a notebook for this class. It could be it's preferably a rule notebook. Long, short, you can decide. Preferably a rule notebook. And maintain a different book. Do not mix up other subjects or something else. Don't use it as a rough notebook. So give the name of the chapter and write out all this in that new notebook. All right, children?
Okay, ma'am.
Yeah.
Okay.
Okay, these we finished yesterday. Yeah. Yes, children. For any two rational numbers A and B, A into B is? For any two rational numbers A and B, A into B is? Okay, let me explain what the statement means.
Yeah.
The product of two rationals is always
AB, ma'am.
no, the product of two rationals is always rational. All right, because there's something else called irrational numbers, which you will see in standard 9. Okay, so here the expected answer is rational, because the product of two rationals is always rational, is always a rational. Let me give you another example. Now, the difference of two whole numbers need not be a whole number. We saw that yesterday. The difference of two whole numbers. Now, consider the whole numbers 25 and 30. The difference of the whole numbers 25 and 30 is -5, which is not a whole number. Which is not a whole number. It's an integer. So whole numbers are not closed under subtraction, meaning the difference of two whole numbers need not always be a whole number. It may be a whole number, maybe an integer. Because the other way around, 30 minus 25 is 5, which is a whole number. So that's why we say whole numbers are not closed under subtraction, because the difference of two whole numbers need not be a whole number. Here in this case, it's an integer. In that sense, understand this statement. For any two rational numbers, A and B, the product, their product is always rational. Understand, children?
Yes, ma'am.
Yes,
Yeah.
ma'am.
For any two rational numbers A and B, their product, that is A into B, is always rational. Okay, dash and dash are not commutative for rational numbers.
Division and subtraction.
Subtraction and division.
Subtraction and division.
Subtraction and division is not commutative. So commutative meaning Now when you take two rational numbers A and B, A minus B is not the same as B minus A. When you take two rational numbers A and B, A minus B is not the same as B minus A. Similarly, A by B, 10 by 5 is not the same as 5 by 10. 10 by 5 is 2. 5 by 10 is 1 by 2. So
Yes.
somebody's mic is enabled. Please disable your mic. Once you answer, kindly disable your mic, children. Once you answer, please disable your mic. Yeah. So subtraction and division are not commutative for rational numbers. Subtraction and division are not commutative for rational numbers. Because when you take two rational numbers, A and B, A minus B is not the same as B minus A. A by B is not the same as B by A. See now, when you take examples like 5 by 5, if A and B are both 5, 5 by 5 is 1. B by A, 5 by 5 is also 1. Okay, for this case, it is true. Is it always true is the question. It may be true. But when can you say it's true? Only when it is always true. There should not be even one exception. In that sense, subtraction and division are not commutative for rational numbers. If M is the reciprocal of N, then the reciprocal of N is
M.
M.
Yeah. So we can take an example. Now the reciprocal of 2 by 3 is 3 by 2. So the reciprocal of 3 by 2 is 2 by 3. They are the reciprocals of one another. They are the reciprocals of one another. So M and N are reciprocals of one another. Because M is the reciprocal of N, it means M and N are the reciprocals of one another. If M is a reciprocal of N, then the reciprocal of N is M. The product of a non-zero rational number. The product of a non-zero rational number and its reciprocal is
1.
1. So consider
One.
any 1. Very good. 1. Because the product of a number and its reciprocal is always 1. So when they say non-zero, that means not 0, except 0. So just remove this. The product of a rational number and its reciprocal. Not 0. Okay, not 0. The rational number is not 0. So the product of a rational number. So some rational number, say minus 7 by 8. And it's reciprocal. Now, children, what's the reciprocal of minus 7 by 8?
Minus 8 upon 7.
Minus 8 by 7.
Minus 8 by 7.
Minus 8 by 7. You only have to invert it. Just invert it. Don't change the sign. Minus will remain. Okay, now let's recall negative of a rational number and reciprocal of a rational number. Okay, when it is negative of a rational number, now supposing 2 by 3, 2 by 3, it's positive 2 by 3. So its negative will be, write the rational number as it is, just change the sign. This is negative. But for reciprocal, see, there are two things which you can do with a rational number. A rational number has a numerical value and it also has a sign attached with it. A rational number has a numerical value and a sign attached with it. For negative of a rational number, you don't disturb the numerical value. You only disturb the sign. That is, if it is positive, you make it negative. If it's negative, you make it positive. See, there are two components. For any number, there are two components. Its sign and its numerical value. When you're writing the negative of a rational number, you're going to manipulate only the sign. Plus becomes minus or minus becomes sign. Sorry, plus becomes minus or minus becomes plus. But the numerical value 2 by 3 is written as it is 2 by 3. It's just the opposite in case of the reciprocal. When it's the reciprocal, write the sign as it is. Invert the number alone. The numerical value is manipulated. That is, put upside down. So what are the two things you can do? You can change the sign or you can invert this 2 by 3. You can invert 2 by 3 and write it as 3 by 2. So two things you can do. Nothing else you can do. At a time, one at a time. Saying one at a time. One at a time, you can change the sign or you can invert the rational number. So for negative, so we'll come again. So supposing the rational number is minus 3 by 4. minus 3 by 4. And you want to write it negative. For negative, write the numerical value as it is. Change the sign, manipulate the sign. Minus becomes plus. But for reciprocal, the reciprocal of minus 3 by 4, don't do anything to the sign. Write that as it is. Invert the numerical value. Put it upside down. So 4 by 3. So only one thing you'll have to do. You should not change both. You should not write, the numerical value upside down and change the sign. Two things you cannot do at a time. Only one you should do. If you change the sign, you're writing the negative. If you write the sign as it is and invert the numerical value, you're writing the reciprocal. Okay. The product of a rational number and its reciprocal is always 1.
1.
So, yeah. Now, sometimes, children have this tendency when you know something, somebody's mic is enabled, children, we shouldn't be wasting time on this instruction. Okay. Okay. No, I was trying to say sometimes when we know something, we turn a deaf ear to the teacher's explanation because I already know it. She's simply going blah, blah, blah. Please have the patience to listen. Please have the patience to listen. Consider this. Okay, I have to repeat the same information year after year. So when I have the patience to do it, you should have the patience to listen to it more than once, even if you know it. Okay, so the product of a rational number and its reciprocal is 1. So minus 7 by 8 is the rational number. Its reciprocal will be, write the sign as it is, invert the number 8 by 7. So the product 8 and 8 gets cancelled, 7 and 7 cancels, minus into minus plus, plus 1. Okay, the multiplicative inverse. Anantika, what is the other term for multiplicative inverse? Sorry, not Aishwarya. Sai Smriti, the other term for multiplicative inverse.
Ma'am, can you repeat?
The other term for multiplicative inverse. Shreya?
Ma'am, is it reciprocal?
Yeah, it is reciprocal. Anantika?
Yes, ma'am.
Yeah, what happened? No problem. Okay. I was asking what is the other term for multiplicative inverse? So reciprocal. Reciprocal. So what's a reciprocal of 5 by 6?
6 by 5, ma'am.
6 by
6 by
5.
5. Is it minus 6 by 5?
No.
No, ma'am.
No, ma'am.
No. It's
No,
just
ma'am.
6 by it's just 6 by 5. Because 5 by 6 into 6 by 5. The product should be 1. The product of a rational number and its reciprocal is always 1, not minus 1. Okay. This is the next one. Yeah, the first one is for Sai Smriti. Sai Smriti, answer the first one.
Yes, ma'am.
Shreya, the second one. Aishwarya can try the third one. And Anantika can try, do the fourth one.
Ma'am, I think C. 0.
So Sai Smriti, which of the following rational number does not have a multiplicative inverse? Why 0 does not have? Explain.
Then B, ma'am.
No,
I
see,
think 0 doesn't
I'm.
have.
Yeah, okay, but your thought you must justify. Why do you feel so? Yeah, Shreya, can you explain that?
The first one, ma'am.
Yeah, Sai's answer. She says
Okay, ma'am.
0.
Ma'am,
Yes, ma'am,
because
it's 0
the inverse
because
of 0 is not
it can.
defined in the number system.
Yeah, Shreya, go on.
Ma'am, the second one is non-zero, ma'am.
No. We're talking about the first one. Who can justify? Sai Smriti, do you
Ma'am,
want to
Anant-
take it up again?
Yes, ma'am. Can I
Sai
tell,
Smriti?
ma'am?
Yeah, Sai
Yes,
Smriti,
ma'am,
do you want to try
because-
again?
Yes, ma'am. This is because the inverse of 0 is not defined the number system.
Okay, somebody else can try. Okay, I'll come back to you, Sai Smriti. Somebody else?
Ma'am, Anantika.
Yeah.
Ma'am, so when you do the multiplicative inverse of 0, you get 1 upon 0, which is undefined.
But how do you know it is 1 by 0?
Ma'am, because multiplicative inverse is reciprocal, so 0 upon 1's reciprocal is 1 upon 0, which is undefined.
Yeah, that is what I wanted. Exactly. Very good. So 0 means 0 by 1. What do you understand by 0? 0 means 0 by 1. Because 5 is 5 by 1. 6 is 6 by 1. In the same way, 0 is 0 by 1. So its reciprocal will be 1 by 0. And we know that 1 by 0 is not defined. Division by 0 is not defined. So this we should be able to express. Because 0 is 0 by 1. Like 5 is 5 by 1. 0 is 0 by 1. In fact, 0 is one number which can be written with any denominator. See, like you cannot write 5 as 5 by 2. Because then you're changing the value of 5. 5 is 5 by 1 because it is still 5. But 5 is not 5 by 2 because 5 by 2 is a different number altogether. But 0 is one rational number which can take any denominator. 0, 0 by 1, 0, 0 by 2, 0 by 3, because everywhere the value is 0. What is 0 by 1? 0. What's the value of 0 by 2? 0. 0 by 3? 0. 0 by 4? 0. 0 is one rational number which can take up any denominator. So supposing we say 0 by 1. Reciprocal is 1 by 0. And division by 0 is not defined. So 0 is a rational number that does not have a multiplicative inverse or a reciprocal. Sai Smriti, you're right. But did you get the explanation now?
Yes, ma'am.
Yeah, so 0 is 0 by 1. And its reciprocal is 1 by 0. But this is not defined. Division by 0 is not possible. So 0 is the rational number that does not have a reciprocal. Shreya, next one.
The product has to be non-zero, ma'am.
The product of two non-zero numbers is always?
It's actually non-zero, ma'am.
Any other answer? Correct. So when you take two numbers which are not zero, something else. So their product, not their sum, their product cannot be zero. Their product cannot be zero. Correct. It's non-zero. Aishwarya?
Yes, ma'am. The identity for the addition of rational number is 0.
Zero. Identity meaning we should get the same answer. The same answer, identical answer. So the identity for addition of rational numbers is 0 because now supposing we have 6 by 7 plus what will give the same identical answer 6 by 7. That's what is additive identity. Identity for addition or additive identity. So you have the rational number 6 by 7 plus what will give you the same number 6 by 7 plus 0. So 0 is called the identity for addition or additive identity. Very good. Anantika?
Ma'am, the answer is 1.
Okay, good. Multiplicative identity is 1. Okay, next one. Anyone can answer?
Ma'am, it's 3, both A and B. Anantika.
Both A and B, is it? Okay. Sai Smriti, tell me, what can you say about this? Just say something about this.
Yes, ma'am. They are actually using the distributive property because
Distributive property, it's not complete. Distributive property
of addition. No, of multiplication over addition.
Very good. It's the so what is stated here is the distributive property of multiplication over addition. Is it stated correctly here? Is this equation correct?
Yes, ma'am.
Very good. Shreya, the next one.
Ma'am, I just need some time.
Aishwarya, kindly disable your mic, Aishwarya.
Yes, ma'am.
Yeah. Oh, I think I lost the slide. One second. Yeah. Yeah, children. What is Shreya? Say something about this one.
It is correct, ma'am. It's obviously distributive property over multiplication of subtraction of rational numbers.
Okay, so it is the distributive property of multiplication over subtraction of rational numbers. Very good. So both A and B are right. Both A and B are correct. So the correct answer is, or the correct option is 3, which is, I've made a mistake in typing here. This one is 1. This one is 1. Okay. So this is right. Very good. Aishwarya, first one.
Yes, ma'am. The absolute value of a rational number is obtained by taking only the numerical value of the rational number. The absolute value of a rational number is obtained by taking only the
Have you
numerical
come
value.
across this term, absolute value?
I'm not able to understand the question.
Okay, fine. So now this is the this is how we this is a symbol used to represent absolute value. So see, it's also called modulus or absolute value of -3. So when you write something like this, it's read as absolute value of -3 is 3. Take only the numerical value, ignore the sign. The absolute value of 3 is also 3, whether it is positive or negative. Its absolute value is only positive. It's always positive. That means we only take the numerical value into consideration. We ignore the sign. Yeah.
Yes, ma'am. I've learned about modulus.
Modulus,
Yeah.
yes.
Yes, ma'am. So the answer is true.
Yeah, this is rational. So the absolute value of a rational number is obtained by taking only the numerical value of that rational number. Correct. So if it is -7/8, we ignore the sign minus. The absolute value of -7/8 is 7/8. The absolute value of 7/8 is also 7/8. It's not -7/8.
Yes,
so basically, absolute value is always positive. Is always positive. And this is how you write. If you want to read something as absolute value of, then you should use a symbol. Absolute value of -3 is 3. Okay, so the first statement is true. Second one. Rational numbers are not closed under addition and subtraction.
Ma'am, it's false.
It's false because they're closed under addition, right?
Addition, ma'am. Yeah, ma'am.
What about subtraction?
Yeah, they're not closed under subtraction, ma'am.
Children, please think again.
Ma'am,
may
it
be
is
right.
closed under subtraction, but it's written are not.
Okay, then is the statement true or false? If it is false, what's the correct statement?
False. The correct statement would be rational numbers are closed under addition and subtraction.
Yeah, so now how do we understand the statement? The sum of two rational numbers, the sum of two rationals is always rational. The difference of two rationals is always rational. It's true, meaning rational numbers are closed under addition and subtraction. But here it's given rational numbers are not closed. They are closed. See, if you're not able to decide, like you're getting confused as to how to understand this. Take an example. Just tell yourself closed meaning when you take two rational numbers and find their sum, the answer is also rational. Yes, it will be rational. Rational means what? It can be an integer, whole number, natural number, anything. It can be a fraction. Yes. Similarly, when you subtract two rational numbers, the result is rational. What else can it be? Rational is a collection of all the numbers you have seen so far. The other thing is irrational numbers, which you haven't come across at all so far. So the collection of numbers which you know now is only rational. The collection of numbers which you know now is rational. Rational is like the universal set for you. So the difference of two rational numbers is always rational, is true. So this statement is false. The correct statement is rational numbers are closed under addition and subtraction. That's the correct statement. Since it's given not, it's false. Next one, subtraction of rational numbers is commutative. So how do you understand this?
False.
So if A and B are two numbers.
Ma'am, it's false.
Yeah, A minus B is equal to B minus A. That's what the statement is trying to say. Subtraction of rational numbers is commutative. Commutative is a different property. Closure is a different property. Commutative means A minus B should be equal to B minus A. No. A minus B will not be equal to B minus A. So this is false. Reciprocal of any rational number is always an integer.
False, ma'am.
False, ma'am.
False. So you can take an example.
False.
Now, if you take the rational number 3 by 2, its reciprocal is 2 by 3, and this is not an integer. So false. This is false. Last one, the numbers 1 and minus 1 are their own reciprocals.
False.
False, ma'am.
True.
I've got both the answers, true, false, which is right.
True. Is it true,
Okay,
ma'am?
all of you can take another chance. Tell me now, true or false? True or false? Well, what happened, children?
I think it's false.
Okay, Anantika, false. Then, anybody else? False?
No, ma'am. I think it's actually true.
It's actually true. Sai Smriti, okay?
Yeah.
Ma'am, it's true.
Shreya says true. It is true. She's sure it's true. Okay. Aishwarya?
Ma'am, I'm not exactly sure.
Okay. Now, what is the reciprocal of you? Actually, I think if you're incorrect, you did not understand the statement, because otherwise you know the answer correctly, all of you. The numbers 1 and minus 1 are their own reciprocals. Okay, what is the reciprocal of 1? What is the reciprocal of 1?
1
1.
1.
What is the reciprocal of minus 1?
minus
1.
1.
What is the reciprocal of minus 1? What did I
One,
tell you? For reciprocal, don't change the sign. Invert the number.
So minus
When
one.
do you change the sign? When do you change the sign for negative of a rational number? You change the sign. Plus becomes minus, minus becomes plus. And the number is written as it is. You don't invert the number. You write the number as it is. But for reciprocal, do not disturb the sign. Minus is minus, plus is plus. Then what do you disturb? Invert it. Put it upside down. So minus 1, its reciprocal will be, don't disturb the sign, minus only. Reciprocal of 1 is 1. Now tell me, 1 and minus 1 are their own reciprocals?
True.
True.
Yeah, so
Yes, ma'am.
Yeah, Shreya was right. Sai Smriti was right, but she was not sure. Okay. So this is true. Yes or no, children?
Yes, ma'am. True.
Yeah. The reciprocal of 1 is 1. The reciprocal of -1 is -1. Which means 1 and -1 are their own reciprocals. Okay. So you need to complete all this also in your book. So take a screenshot. Let me just clear this annotation. Please wait. Yeah. Take a picture, children. Take a screenshot.
Yes, ma'am.
Yeah. 1 minute. Let me clear the annotation. Yeah. Now take a picture. Done, ma? Done, children?
Yes, ma'am.
Yeah. 1 minute. 1 minute. Let me clear this. Yeah. Now. Yes.
Yes, ma'am.
Okay. Yeah.
Yes, ma'am.
Okay. So this is the, you can take a screenshot now, children. Take a picture now.
Done, ma'am.
Yeah. Now the heading is match the columns. A statement in column 1 can have multiple answers in column 2. And you can use the same answer again for the others. We have 5 statements, 5 incomplete statements in column 1. So you'll have to complete those statements with the correct option in option or options in column 2. And you can use the option more than once. Am I clear, children?
Yes, ma'am.
Yes,
Yeah.
ma'am.
I'll just get back in some time, 2-3 minutes. Okay, I'll just get back. Keep the answers ready for this. All right. You don't have to write anything in your notebook. Just mark, just write out the answers. Like for A, like 1 and 2 is the answer. For B, whatever. Just keep the answers ready. I'll just come back in 2 minutes. Are we ready, children?
Yes, ma'am.
Yeah. So the rational number which is equal to its negative.
Ma'am, is the answer
Zero.
negative of
Zero.
1?
0.
The rational number which is equal to its negative.
Anantaka 0.
0, ma'am.
0.
Choice would be 0.
0. Because what is the, see, these two cannot be the answer because these are not rational numbers. They represent mathematical operations. So we have only three numbers, 0, 1 and negative of 1, which is -1. Okay, so now from these three, what is the negative of 0? 0 is actually
0.
neither positive. Yeah, 0 is an
0.
integer, which is neither positive nor negative. 0 is an integer. So 0 is an integer which is neither positive nor negative. All right.
Yes.
So its negative is 0. The negative of 1 is -1. And the negative of -1 is 1. So the rational number which is equal to its negative is 0. Is 0. The correct answer is 3. The rational number which does not have a reciprocal is
0. 0,
0.
ma'am.
0.
Choice would be 0, ma'am.
Correct, correct. 0 does not have a reciprocal. Okay. The rational numbers which are equal to their reciprocals.
1.
1.
1
One.
and negative of 1.
Shreya,
1
1.
and, yeah. 1 and the negative of 1. The negative of 1 meaning it's -1. What do you mean by this? What does this represent? -1. Negative of 1 meaning -1. So the rational numbers which are equal to their own reciprocals are 1 and -1. So the fifth option also. Yes or no?
Yeah,
Yes,
ma'am.
1 and -1 are their own reciprocals. The next one, if 0 is excluded from the collection of rational numbers, then the rational numbers are closed under
division.
Shreya,
Choice would
division,
be
ma'am.
Division.
what about subtraction?
Yes, ma'am. Both.
Both are only division. If
Only
0 is
division, ma'am.
excluded, only
Division.
Division.
all of you, is it?
Me and
Yeah,
Shreya.
Yeah, ma'am.
Okay, if 0 is excluded from the collection of rational numbers and rational numbers are closed under meaning the difference of two rationals is rational. The quotient of two rationals is rational.
Ma'am, I think it is both division and subtraction.
Yeah, see, that's what it is. We are too, I think, hasty, or we are not considering the meaning of the word closed. You see, because I've often seen children getting slightly, not confused. You're clear with the difference, but then some mental block, at that time of answering. So now, see, we said only division, now subtraction and division. That's why you should take the meaning. Closed under means what? What is closed under? That means when you take two rational numbers, their difference is always rational. I told you that, or you all know that you have only learned rational numbers now. The collection of numbers which you know now are only rational. You don't know anything other than that. So when you take two rational numbers and find their difference, it will be rational for you. Yes or no, children? That only is the collection of
Yes,
numbers
ma'am.
you have now. Yeah. And then similarly, when 0 is excluded, then rational numbers are closed under. That means when you divide two rational numbers, the result is also rational. True. Because
Yes, ma'am.
only if 0 is there, it's not true. Because division by 0 is not defined. When you divide by 0, you will not get a rational number. Closed means this. Whenever you see, when it is closed, take the meaning. If a and 2 are rational numbers, A plus B is also rational. A minus B is also rational. A into B is rational. A by B is rational if we don't include 0.
Yes, ma'am.
A and B are two rational numbers. When A and B are two rational numbers, A plus B is rational. A minus B is rational. A into B is rational. A by B is rational when B is not 0. So if you exclude 0, then A by B is also rational. So here it is for both subtraction and division. If 0 is excluded from the collection of rational numbers, then the rational numbers, see, 0 does not affect subtraction. 0 affects division. 0 does not affect subtraction. So if this is excluded, they're closed under 1 and 2. Is it clear, all of you?
Yes, ma'am.
Okay. Both natural numbers and whole numbers are not commutative under
Subtraction. and
Subtraction, ma'am.
division. Ma'am, both subtraction and division for an integer.
Yeah. Natural numbers and whole numbers are not commutative under. Commutative meaning A minus B, B minus A. If A minus B is A minus B and B minus A, you must get the same answer. Commutative means what? A minus B answer should be the same as B minus A answer. A by B answer should be the same as B by A answer.
So Antika said both subtraction
Both, yeah,
and division.
Yeah, you said both, yes. Natural numbers and whole numbers are not commutative. Commutative means what? Okay, we'll leave that natural numbers and whole numbers. What do you mean by the commutative property? For commutative, we consider only two numbers. Associative, three numbers. Association, if you see in the dictionary, it means a group. Association, group. So for associative property, we take A, B, and C. Commutative, only A and B. Two numbers. Commutative means A plus B should be equal to B plus A. A minus B, B minus A. A into B, B minus A, B into A. Should be the same answer. A by B, B by A. The answer should be the same both the ways. The answer you get for A minus B, you must get the same thing for B minus A. Then commutative. The answer which you get for A by B, you must get for B by A also. Then commutative.
Yes, ma'am.
Yes,
So
ma'am.
the answer is subtraction and division for the E.
Subtraction and division. Yes. So both natural numbers and whole numbers are not commutative. Because when A and B are two natural numbers, so like say 5 and 4, 5 minus 4 is not the same as 4 minus 5. And 5 by 4 is not the same as 4 by 5. So for the last one, it is subtraction and division also. Division also will not be true. A by B is not the same as B by A. The answers will be different. Okay. So I think this you should take a screenshot along with the answers also, children, so that you can just check. Yeah. You've already taken a screenshot. Now take a screenshot again.
Yes, ma'am.
Done, ma'am.
Yes, ma'am.
Okay. Yeah, I think we should start working today. Where am I? Okay. Yeah, you all can take a picture of this one.
Yes, ma'am.
Yeah. Now, Aishwarya, try the first one. See, you missed the first session. So I don't expect you to answer correctly, but still you can try.
Yes, ma'am.
Yeah. Children, I just want to say that these questions only, I've placed it one by one here. It's the same. I asked you to take a screenshot, right? So here you have from A to F. They're the same questions here. A to F, I've just put the question separately here. Yeah. Okay, I think it won't be right on my part to ask Aishwarya. You can just follow this class, Aishwarya. Please make sure that you watch the recording before the next class, okay?
Yes, ma'am.
Yeah. Yes, who wants to try this?
Ma'am, me.
Yes,
Can I
Smriti? Yes, Smriti. Yes, Smriti?
Yes, ma'am. Roll of 1
Louder.
or multiplicative identity.
Multiplicative identity.
Yes, ma'am.
Okay. What is the multiplicative identity?
1.
1. Very good. What about the others? Agree with Smriti?
Yes, ma'am.
She says the property of multiplicative identity is reflected here. Yes. Multiplicative identity. The existence of multiplicative identity. That property is reflected here. So sometimes it's
Yes, ma'am.
the existence. What property is reflected here? The existence of multiplicative identity. Multiplicative identity is shown here. Is reflected in this equation. This is enough. The existence of multiplicative identity. So a rational number multiplied by 1 is equal to 1 multiplied by the same rational number is equal to the rational number itself. Okay. So see, if you feel you want to write the answer, you can take a picture. So I don't have to tell you to take a screenshot. Wherever needed, you can take a screenshot.
Ma'am, can we also say the roll of 1?
Yeah, that's the heading. I had given the role of 1, but it's better we say it is the whatever I've written here, or you can simply say multiplicative identity.
Yes, ma'am.
Again, different teachers have, different ways of expressing the concept. So if your teacher uses that in school, yes, you can go ahead with that.
Yes, ma'am.
Yeah, but this will be appropriate. What I've written here. Yes, somebody else try this. Quickly, children.
Ma'am, Anantaka.
Ah.
Commutative property.
Ma'am, may I try?
Yeah.
Ma'am, I think
Associative property of multiplication.
Yeah. Was it Aishwarya?
Yes, ma'am.
Very good. Okay. Associative property, because we see 3 different rational numbers, 2 by 3, 5, and 6 by 7. We see 3 different rational numbers, 2 by 3, 5, and 6 by 7. 3 different rational numbers means associative property of multiplication of rational numbers. Associative property. Associative property of multiplication. You should complete that, of multiplication. Next one. Anybody?
Ma'am, I think it is associative property. Yes, ma'am.
Again.
Try, Smriti. Yes, ma'am.
Associative property of multiplication.
Correct.
Over
Associative. Over addition, huh? Did somebody say over addition?
No, ma'am. No, ma'am.
No. Associative property of multiplication, because the three different rational numbers are 4 by 5, minus 3 by 5, and 1 by 2. You can see the same here, 4 by 5, minus 3 by 5, and 1 by 2. Just that the brackets are used in different ways. So it's associative property of multiplication. Yeah.
Can I tell this, ma'am?
Yeah. Saraswati.
Distributive property of multiplication over addition.
Very good. Distributive property of multiplication over addition. Correct. So 1 by 2 into 1 by 5 plus 1 by 2 into minus 1 by 7. 1 by 2 into 1 by 5 plus 1 by 2 into minus 1 by 7. Perfect. Distributive property of multiplication over addition. Distributive property of multiplication over addition. Half into 1 by 2 into 1 by 5 plus 1 by 2 into minus 1 by 7. 1 by 2 into minus 1 by 7. So as the distributive property states, you can see two products here. This is one product, this is the other product. So, but there's only one product here. I told you this in the last session. There's only one product here. You can see only one multiplication sign here. But here you can see two multiplication signs. So one product is split as two products. The sum of two products. One product is split as the sum or the difference of two products. There's only one product here. But here there are two products. You can see a product here and you can see a product here, and the products are connected by the plus sign. So, writing a product as a sum of two products is what is the distributive property. So this is distributive property of multiplication over addition. Yeah, this one.
Can I tell it, ma'am?
Yeah, anybody? Yes.
Additive identity.
Additive identity.
Additive identity.
Is it additive identity?
Yes, perfect. Additive identity. The existence of additive identity. You can simply say additive identity, or you can say the existence of additive identity. Because any rational number plus 0 or any rational number plus 0 is equal to 0 plus any rational number is equal to the rational number itself. Or if I have to say this in words fully, the sum of a rational number and 0. The sum of a rational number and 0 is the same as the sum of 0 and the rational number is the same as the rational number itself.
Yes, ma'am.
Yeah. So additive identity. Yeah. This one?
Can I say?
Yes.
Ma'am.
Anybody?
Associativity of addition, ma'am.
Associative property of addition or associativity of addition. Both are right. Okay. So associativity, because you can see three different rational numbers, 1 by 3, 4 by 9, minus 4 by 3, 1 by 3, 4 by 9, minus 4 by 3. But the brackets are used in different ways. So here, these two numbers are grouped, 4 by 9 and minus 4 by 3. But here, 1 by 3 and 4 by 9 are grouped. Perfect. Associative property of addition. Associative property of addition. Associative property because there are three different rational numbers. So associative property, and it's of addition because you can see the plus sign. All right. Now this is your homework. Take a picture.
Done, ma'am.
Yeah, this we are not discussing in the class now. We'll see the answers in the next class. So keep the answers ready by the next class on Monday.
Okay, ma'am.
Yes,
Yeah.
ma'am.
Yeah. This one also. This is your homework for the weekend. Keep the answers ready by Monday.
Yes, ma'am.
Yeah. Yeah. Now I'll work one of this. The rest is homework. Now, X should be added to Y. X should be added to Y to get Z. Find the, so this is the information given. X should be added to Y to get Z. Find the value of the missing variable in the following. Okay. So these are 4 independent questions. This is one. This is the second one. This is the third one. This is the fourth one. In all the questions, you have 3 variables, X, Y, and Z. Everywhere you have 3 variables, X, Y, and Z. Now, in the first one, Y and Z is given to you. So you should find the value of the missing variable X. In the second one, X and Y is given to you. You must find the value of the missing variable Z. In the third one, X and Z is given to you. You should find the value of the missing variable Y. And the fourth one, X and Z again is given to you. You should find the value of the missing variable Y. Okay, now what is the equation given to us? X should be added to Y to get Z. Am I right, children?
Yes, ma'am.
Yes, ma'am.
X should be added
Yes,
to
ma'am.
Y to get meaning equal to Z. So this is the equation that is to be applied for all the 4 situations, all the 4 questions. So see how I do the first one. 1. So the second one will be not the second one. The third one is a test. Okay. I'll do the first one. The third one is a test. Okay. Now see the first one. You must first start like this. Given presentation is very important. Given X plus Y is equal to Z. Now, we are working the first one. X, we don't know. Plus Y. Y is 9 by 4. Is equal to Z is equal to minus 5 by 12. Is this understood?
Yes, ma'am.
Yes,
So
ma'am.
X is equal to minus 5 by 12. And you'll have to transpose 9 by 4. So it becomes minus 9 by 4 on the RHS. Do we know that?
Yes, ma'am.
Yes, ma'am.
Yeah, ma'am.
When you transpose plus 9 by 4 from the LHS goes to the RHS as minus 9 by 4. Now, what's the LCM of 12 and 4?
12.
12. 12 is the LCM. So 12 into 1 is 12. So multiply that to the numerator. 4 into 3 is 12. The LCM is 12. So you should bring the denominators to 12. So 4 into 3 is 12. Do that in the numerator into 3. So now the denominator 12 we have. 12 into 1, 12. 4 into 3, 12. So that's the common denominator 12. Now the numerator is minus 5 minus 27. So the value of X is equal to minus 32. Minus 5 minus 27 is minus 32 by 12. You must always simplify. So in the tables of 2, 16 times. And this is 6 times. Further, 8s are 3s are. So the value of X in the next line, I'll write it here. So the value of X after simplifying, the value of X is minus 8 by 3. All right.
Yes,
Yeah,
ma'am.
ma'am.
Yeah.
Got it.
Yeah. Now write this in your notebook. Now, children, no, we'll do one thing. It's already 8:35. It's difficult to judge how many pages to leave. Okay, do it. Okay, take a screen. Yeah, that'll be better. Take a screenshot of this one, children. And do the third one in your rough notebook, not in your, this book which you keep aside for this class. Take a screenshot of this. Work this in your, that notebook later. Take a picture of this one, all of you, and try the third one in your rough notebook. Yeah, and your time starts now. Let's see who will give me the answer first. The correct answer first.
Done, ma'am.
Completed, ma'am.
Yeah, what's the answer? What's the value of y?
10 by 91.
6
Sorry.
by 91.
Minus 10 by 91.
Minus 10 by 91. Others are still doing?
Yeah, ma'am.
Okay, finish it, finish it. 1 more minute.
Yes, ma'am.
I'm sorry, ma'am. I think I got it wrong. Hello, ma'am.
Yeah. I'm right here. I'm right here. Yes.
Yes,
Yeah.
ma'am. Actually, the answer is minus 88 by 91.
My God. Okay. All right. I'll just record your answers. I'll just write it down here. Yes, Anantika, your answer?
Ma'am, I'm doing 1 second.
Okay. Don't mind when I don't write your names completely, children. Yes, Shriya,
Yes, ma'am.
your answer?
I'm still working, ma'am.
Okay. Aishwarya?
Ma'am, just 1 second.
Okay. Sai Smriti?
Minus 88 by 91.
Okay. Yeah, I want the answers. Others.
Ma'am, setting it as minus 47 by 72.
Who's that?
Aishwarya.
Minus 40?
7 by 72.
72. Okay. Yeah, I'm waiting for the answers from Anantika and Shriya.
79 upon 72.
Okay. Shriya?
Ma'am, you should actually.
Just a second, ma'am.
Hello, ma'am.
Yeah. I'm right here. Yes.
Yes, ma'am. We should actually do the second sum right now, ma'am.
யார் அது இந்த கேள்வி கேக்குறது இப்போ? Who is that?
Sai Smriti, ma'am.
Second one நான் second தான்
Okay.
சொன்னேன். நான் third
Yes, ma'am.
சொல்லல. Children, what did I
No,
say? Second or third one, children?
Third, ma'am.
One is the third one.
Okay.
Then
Third
I
one,
did wrong.
darling. You did
I
the
did
second
wrong.
one, is it?
Yes, ma'am.
Okay, fine, children. We cannot spend any more time
Ma'am,
on this. I'm working the
I
answer.
also got
Yeah,
also
Shriya.
got 47 by 72, ma'am.
47 by 72. Just 47 or minus 47?
Just 47.
Okay, same.
Yathin, just
I'm removing Sai Smriti's answer because she said that was the second one. Okay, now 7 by 8 plus y is equal to 4 by 18. Now, since 4 by 18 can be simplified, you can simplify it. Disable your mic, children. You can simplify this. So 2 times and this is 9 times. So y is equal to 2 by 9 minus 7 by 8. Y is equal to, the common denominator is 72. 9 into 8 is 72. 8 into 9 is 72. So this into 8, do it in the numerator also. Into 9 in the numerator. 2 8s are 16 minus 7 9s are 63. And y is equal to 63 minus 16. 63 minus 16. So 747 minus 47. Okay, so y is equal to minus 47 by 72. And who's that? Aishwarya. Is right. Shreya, 16 minus 63. Different sign, subtract and put the sign of the greater number. Minus 47 by 72. Well done, Aishwarya. You tried it correctly.
thank you. Thank you, ma'am.
Anantika, let me know where you went wrong. Anantika, I'm scared you have written x plus z is equal to y or something like that.
No, ma'am, I did not simplify 4 upon 18.
No, that's okay. Still, you'll get the same answer. See, I'll do it for you without simplifying. Okay, what's the answer? You got 79 upon 72 is not possible. Okay, we'll do without simplifying. So x plus y is equal to z. 7 by 8 plus y is equal to 4 by 18. Y is equal to 4 by 18 minus 7 by 8. What's the LCM you got for 18 and 8? 72, right?
Yes,
So 4
ma'am.
times
Yes.
into 4. And this is into 9. So it will be
Yes.
16. 16 minus
63.
is 18 fours are
Yes,
18
ma'am,
fours
18
are
fours.
No, I accidentally added it instead of subtracting.
18 fours are 72.
yeah. Okay, so y is equal to whatever minus 47 by 72. So it's the same in both the cases.
Went wrong because I added instead of subtracting.
Okay, fine. Got it, children? All of you? So this is how you find
Yes,
the value
ma'am.
of the missing variable. Please try 2 and 4 by yourself and see in the fourth one also 3 by 21 can be simplified. You must always simplify. You substitute as it is and then you simplify. 3 1s are 3, 3 7s are 21. Wherever possible, you can simplify. Even if you forget to simplify, you will get the same answer. We cannot get different answers. Yeah, you can take a screenshot if you want. Yeah. Now here I'll just give you the equation. Try the third one. I'll just give you the equation. X should be subtracted from Y to get Z. Help me construct the equation, children.
Is this the
X.
fourth one we have to do now?
No, third one. But first, let's construct the equation. We'll do the third one as test now. What's the equation?
Y minus x is equal to z.
Y minus x is equal to z.
Yeah, subtracted from y. So y first minus x is equal to z. This is what is given to us. Given x should be subtracted from y. So after from we have y. So write that first. Minus x is it to get meaning equal to z. Yes. Third one is a test. All of you do the third one.
Mom, I'm getting 191 by 1 to 1. 191 by 121.
No, I got 191 divided by, sorry, no, by 121.
Same thing. Yeah.
So
Okay. Okay.
I got 191 divided by 1 to 1.
Okay. Very good. All the three of you.
Same answer, ma'am.
Very good. Okay. So y is not known. Y minus x 17 by 11 is equal to z 4 by 121. So y is equal to 4 by 121. This one goes to the other side plus 17 by 11. And the LCM of 121 and 11 is 121 itself. So 121 into 1 is 121. So 4 into 1, 4 plus 11 into 11 is 121. So into 11. So 170 plus 17 is 187. 187. So y is equal to 191 by 121. Very good. Very good. All of you got the correct answer. So that's about this one. Yeah. We'll do the fourth subdivision here. The fourth subdivision. Tell me the equation.
X into y is equal to z.
Equal to z, yes, ma'am. So y is equal to z.
Given
We
x
have to
into
do
y.
the fourth one, right?
Yeah. Fourth one.
Mom, I got 105.
105. Okay.
Yes, ma'am, even I'm getting 105.
105. Okay.
Mom, you have written.
No, I just didn't want to sit idle, so I was working the second one.
Okay.
Yeah, the fourth one. X into y is 15 by 91 is equal to z is equal to minus 225 by 13. So x is equal to, now this is in product form here. In the left hand side, we have x into 15 by 91. So we have a product. So now this 15 by 91 will go as its reciprocal on the other side. 15, supposing it was plus 15 by 91, then on the other side it will be minus 15 by 91, minus 15 by 91. This is into 15 by 91. So on the other side it will be into its reciprocal, 91 by 15, because it will go for division. And if it's division, it will be multiply. When it's division, you change that to multiplication and you write the reciprocal, right? So we'll do that directly. We'll do that directly. So x is equal to minus 225 by 13. Now this is into, it's not plus 15 by 91. If it was plus, then it will be on the other side minus 15 by 91. But this is into. So on the other side, it will become into its reciprocal, 91 by 15. So X, you should write this step directly. Now, 15 ones are 15, 15, 15 times, 225. 13 ones are 13 sevens are. So it's minus. Girls, you forgot the minus sign. Minus. It's minus 105. 15
Oh yes,
into 7.
I missed minus 15. Yeah, it's minus 1.
Ma'am, I got the correct answer, ma'am.
Very good. Minus 105. This is the presentation. Second one is x into y is equal to z. So x into y, no reciprocal and all that. Just write x and y, multiply, and that is z. So you just have to simplify. Simplify and you get 85 by 18. So if a fraction is in product on one side, on the other side, it will again become, it will be a product with its reciprocal. So into 15 by 91, when you transpose, it will be into 91 by 15.
Yes, ma'am, got it.
Yeah. Now together we'll do the second one, and I'll give you one more for test. Together we'll do the second one. X should be divided by y to get z. Or you can also write it like this, x, because you have fractions, no? So it's convenient to write like this. You can write it like this because they're fractions. X divided by y is equal to z, like this. Now, if I do the first one, say first one, x divided by y, that is minus 3 by 18, is equal to z, minus 144 by 135. All right. So now be very careful. Listen to me very carefully, children. I'm sure you can go wrong. Now listen to me. X, never, whenever you find the division sign, immediately change that to multiplication and take the reciprocal. So this division will become multiplication, and minus 3 by 18 will be written as its reciprocal, minus 18 by 3 is equal to, okay, and you can simplify this. No, I forgot. 3 ones are 3 ones are and 3 6 are. No,
Ma'am,
I
I
forgot.
solved and I got the answer as minus 7 upon 13.
Okay. Okay. So 1s are 3 6 are 18. So in the next step, children, x into division becomes multiplication, and minus 1 by 6 becomes its reciprocal. That is 6 by 1, which is 6. So minus 6 is equal to minus 144 by 135. So now x is equal to minus 144 by 135. Now what is this? Into minus 6, right? So what did we understand in the last sum? It'll be into, this is like minus 6 by 1. So it'll become minus 1 by 6 on the other side. It'll become its reciprocal on the other side. So minus 6 means minus 6 by 1. So it'll become minus 1 reciprocal. So write the minus sign. 6 by 1 will become 1 by 6. So now 6 ones are 6, 6 twos are 12, 6 fours are 24. Okay, so x is equal to minus 24 into minus 1. So it will be plus 24.
24
Minus
upon
into
135.
Yeah, but you can simplify this further in the tables of 3. So 3 8s are 24, 3 45 times. So 8 by 45. X is equal to 8 by 45. Now, how do we realize that the numbers are divisible by 3? By using the test of divisibility. Because 135, the sum of the digits is 9. 1 plus 3 plus 5 is 9. And 9 is divisible by 3. So 135 is divisible by 3. So you must use the test of divisibility.
Ma'am, I thought you were doing the second one. So for that, I got the answer minus 7 upon 13.
Okay, fine. No, I just like strike this out and I said we'll do the first one. No problem. I did say the second one first. Is this fine, children? The first
Yes,
one?
ma'am.
Yes, ma'am.
Yes, ma'am.
Yeah, if you
Yes,
just want to
ma'am.
practice, I'll wait for a minute. If you just want to practice this in your book, I'll just wait for a minute.
Yes, ma'am.
Yeah. Now try everything, children. Please practice this and try the rest. 2, 3, and 4. All the three. Please try. I have word 1, the first one. Please try 2, 3, and 4. Yeah, I'll just get back in some time. Please work.
Done, ma'am.
Yes, one of you read out the steps from your notebook.
Ma'am, for the second one, ma'am, may I?
Yeah, tell me.
Yes, ma'am. So, x is 13 upon 18 into 126 upon 169.
No, no, I want all the steps. First, we'll have to substitute. So 13 by 18 divided by minus 169 by 126 is equal to Z. First step is to substitute.
Okay.
Yeah, next.
Is equal to Z. So, 13 upon 18 into 126 upon minus 126 upon 169 is equal to Z. If we reduce, we will get 7 on the numerator and 13 on the denominator.
Which one did you reduce? I'm cancelling 13 and this one. 13 ones are 13, 13 13s are 169.
Yeah.
Then 18 and
18 ones are 18, 18 sevens are.
18 7 times, is it?
Yeah.
Okay, fine.
Ma'am, minus
7.
7 by 13.
Yeah,
minus
7
is here.
by 13.
No, minus is here. Yeah, minus is there.
The answer
18
is minus 7 by 13.
So now when you multiply 1 into minus 7, you have 1 and minus 7 as the numerator. So 1 into minus 7 is minus 7. And the denominator, we have 1 in 13. 1 into 13 is 13. So Z. So Z is equal to minus 7 by 13. This is the answer for the second one. Very good. Somebody else? The third one? Yeah? Anantika tried the second one. Somebody else? The third one? Okay, I'll do it. So x minus 15 by 19 divided by y is equal to z 90 by 247. Now, whenever you have this division symbol, you have to change it to multiplication immediately in the next step. So minus 15 by 19, division becomes multiplication and y is written as its reciprocal. Y by 1 is 1 by y is equal to 90 by 247. This is the second step. This is the second step. Do you all have this?
Yes, ma'am.
Okay. Now in the next step, 1 by y is equal to, so you need to have the variable on one side and collect the fractions or the rational numbers on the other side. So 1 by y is equal to, now this, these two are as a product here. So when you transpose minus 15 by 19, it will go as its reciprocal on the other side. Okay, so it will be, because it's in product, so it will go for division. Product will go as division on the other side, not minus becomes plus. That is when they are under addition or subtraction. Now this is a product. So when you're taking minus 15 by 19 from a product to the other side. So it will go to the other side as into its reciprocal, because divided by on the other side it will be division. So division becomes multiplication and it becomes its reciprocal on the other side. So the reciprocal of minus 15 by 19 is minus 19 by 15. Now you need to simplify this. So in the tables of 5, 18 times 5 3s are 3 1s are 3 6s are. And in the tables of 19 and 247, 19 1s are 19. I'm just checking if it's exactly divisible. So 19. Okay, so 5 and 7 comes down. 19 3 times 57. 0.
No, it's not. Wait, is it? Yeah, it is. Sorry.
19 ones are 19 13 times. So we have 1 by y is equal to, what do we have in the numerator? I can see a 6 and minus 1. 6 into minus 1, which is minus 6. And the denominator, I think we have only 13. So now 1 by y is minus 6 by 13. So taking reciprocals on both the sides, we have y is equal to minus 13 by 6. What is this here? We take reciprocals on both the sides. You can do anything. Now, when you have an equation, you should do the same action on both the sides. You must do the same action on both the sides. So you're writing in the left-hand side, you're writing the reciprocal of 1 by y. So right-hand side also, you should write the reciprocal of minus 6 by 13. So minus 6 by 13. So we say taking reciprocals on both the sides. So 1 by y is y. At the same time, you should take reciprocals on both the sides. So 1 by y is y. And minus 6 by 13 is minus 13 by 6. So the value of y is minus 13 by 6.
Ma'am, I have a doubt.
Yeah.
Ma'am, if minus 6 by 30, minus 6 is negative, then how can minus 13 be negative when it's turned around?
No. See, now this minus sign, you don't have to attach it to any the number here. Minus is something which is common to the fraction. The fraction is 13 by 6. It's negative. That's all. That's the meaning.
Okay,
It's the
ma'am.
same. Okay, I'll tell you like this. Minus 13 minus here 13 by 6 is the same as minus 13 by 6 is the same as 13 by minus 6. Because
Yes, ma'am.
how will you find the value of 13 by minus 6? You are not going to divide 13 by minus 6. You are going to divide 13 by 6 and to the quotient you're going to fix a minus sign. That's all. Okay,
Yes,
let me,
ma'am.
one second. Now supposing you'll have to find 8 by minus 4. 8 by minus 4. You are not going to divide 8 by minus 4. You're going to divide 8 by 4. The result is 2. And to the result, you're going to fix a minus sign, minus 2. Supposing you have minus 8 by 4. Minus 8 by 4. The result will have a minus sign. 8 by 4 is 2. So minus 2.
Understood, ma'am. Now I got it.
Yeah. I'll work the third one again. I'll work the third one again. Can I clear the slide, children?
Yes, ma'am.
Yes, ma'am.
Okay. So we'll see the third one again. The given equation is x divided by y is equal to z. Why are we writing like this? Why not like this? Because the given values of x, y, z, they are in fractions. So it's easier to write it like this. X divided by y is equal to z. Now, in the third one, we have x is minus 15 by 19 divided by y is not given. So divided by y is equal to z is 90 by 247. Now, whenever you have this division sign in an equation, the first step, the meaning immediately in the next step, what you have to do, get rid of the division sign. That is, change division to multiplication and write the next fraction as its reciprocal. So write minus 15 by 19 as it is. Division becomes multiplication. Now the fraction following the division sign, which is y. Y is y by 1. So its reciprocal is 1 by y. Division becomes multiplication and y becomes its reciprocal 1 by y because y by 1, so it becomes 1 by y. Write the others as they are, 90 by 247. Now here, now the idea is you need to have the variable whose value we have to find on one side and all the rationals or the numbers on the other side. So in that, so keeping that in mind, we'll have to shift this one to the other side. We'll have to shift minus 15 by 19 to the other side. We need to transpose that. Okay, and here these are in connected with the multiplication sign. So on the other side, minus 15 by 19 will go as division. Okay, so write 1 by y as it is. Write this equal to sign. Write this fraction 90 by 247. Now minus 15 by 19 is connected with the product sign, meaning it's in multiplication on one side. So now on the other side, division divided by minus 15 by 19. So instead of showing the division sign, write into and write its reciprocal. So when minus 15 by 19 is transposed or taken to the other side, it is written as its reciprocal 19 by minus 15 or minus 19 by 15. Don't worry where you put the minus sign. You can put it in the numerator or in the denominator, anywhere. That's okay. That's fine. Now we'll have to simplify. So 15 ones are 15, 15 6 are 90. And then 19 ones are 19, 19 13 times. So we have 1 by y is equal to, here in the numerator you have 6 and minus 1, 6 into minus 1 by, in the denominator 13 and 1. So you'll have to multiply. Multiply the numerators, multiply the denominators. So 1 by y is equal to minus 6 by 13. But we need to find the value of y. So taking reciprocals on both the sides, y is equal to minus 13 by 6.
And we can also write it as 13 by minus 6, right?
Yeah. Also 13 by minus 6. Or you can write it as minus 13 by 6. Meaning you can put the minus sign in the middle. 13 by 6.
Okay.
Okay, ma'am, I understood.
Yes.
Very good. So in the same way, you can practice the fourth one at home. It's similar to the third one. X and Z are given. You need to find the value of y.
Yes. And for that, I'm getting 6 by 5.
6 by 9, huh?
6 by 5.
6 by 5. Okay. Any doubts here, children?
No, ma'am.
No.
No, ma'am.
Okay. Okay. Yeah. Try the second one. We'll do it together. I think we'll do it together. We'll do the first one. So see, so we have a set of how many questions here? Whatever. These questions are what I put it one by one here, children. One by one, you can see them here. So we'll try the first one. The presentation is very, very important. It's not about getting the right answer. It's about how you have presented your answer. The sum of two rational numbers is minus 5. Okay. The sum of two rational numbers is minus 5. If one of them is minus 11 by 5, find the other. So see here, one number plus, or you can write one rational number. Okay, one number or one rational number. Please write it like this. Listen to me. One rational number plus other rational number is equal to the sum. This is the equation. Now, one of them is minus 11 by 5. So one rational number is minus 11 by 5. Plus the other one we don't know. We'll call it x is equal to the sum, which is minus 5. Is this understood?
Yes, ma'am.
Yes, ma'am.
Got
One
it, ma'am.
rational number plus the other rational number is equal to the sum. One of them is minus 11 by 5. Plus the other one we don't know. So when before you start this, you can write let the other rational number be x. Let the other rational number be x is equal to the sum minus 5. So x is equal to minus 5. Now here the connecting symbol is plus. So minus 11 by 5 will not become its reciprocal on the other side because here it is addition. It's not multiplication. If it was multiplication, it will go as its reciprocal on the other side. So here minus 11 by 5 on the other side will be plus 11 by 5. Am I right, children?
Yes, ma'am.
So x is equal to LCM, common denominator 5. So here it's like 1. So 1 into 5. So into 5 here. And here it is 5 into 1. So into 1. Minus 25 plus 11.
Be minus 14.
So x is equal to minus
14
14.
upon 5.
Yeah. Just a minute, children. Done, children?
Yes,
Yeah, ma'am.
Yeah. See the next one. See, you can alternatively take screenshots, children. Just a second. Yeah. Children, listen to this carefully. So all that has been covered in the last two sessions must be written out in your notebook. Please complete all this in your notebook.
Ma'am, in the starting, you were showing a homework with a table, right? If rational number integers, is it closed in division, subtraction? So do I have to do that in the notebook also?
Yeah, that final table, no, where we have to tick.
Yes, ma'am.
Yeah, that whatever screenshot you have taken, only those you'll have to complete.
And do I only have to do the homework in the notebook, or also what we did in class right now?
Yeah, the definitions and everything we learned in the class. Yes. All the contents of the screenshots that you have taken today, all that must be reflected in your notebook.
Okay, ma'am.
Yeah.
Ma'am, should we write
Yeah.
also the questions, ma'am?
Yes, darling. Yes,
Okay,
yes.
ma'am.
You must write the question. Yes.
Okay, ma'am.
Yeah. Yeah. If the area of a rectangular room is 45 1 by 4 meters square and breadth is 9 3 by 7 meters, then find the length of the room. So what's the equation here? I'm very particular about the equation. Like for the earlier one, I wrote one number, one rational number plus the other rational number is equal to the sum. So
Ma'am,
here,
so
what
it
is the
will be,
equation?
yes, ma'am. So
Yeah.
area of rectangular room 45 upon 1 upon 45 1 upon 4 meters square is equal to,
Okay.
Ma'am, if we convert it, it is 181 by 4.
breadth is 9 3 upon 7
Ah,
and length we'll keep as x. So area of a rectangle is always length into breadth. So 9 3 upon 7 into x is equal to 45 1 upon 4 meters square.
very good. Very good. Correct. Correct. Yeah. So we'll write the equation first. Solution. So we know that L into B is equal to area. L into B is equal to area. Okay. Correct. So length is not given. So maybe you can keep L as L itself. So L into B is 9 3 by 7. 9 3 by 7 is equal to area, which is 45 1 by 4. So L into a mixed fraction, convert this to an improper fraction, 63 66 by 7 is equal to 181 by 4. Next step, L is equal to,
L is equal to 181 by 4 divided by 66 by 7. So 181 by 4 multiplied by 7 by 66.
very good. So L is equal to, simplify, okay. So now how do we, understand if Our answer is in the simplest form. Now look at the denominators. 4 is divisible by 2. 4 is divisible by 2. Now 66 is divisible by 2, 3 and 11. Because what is 66? 66 is 2 3s are 6 into 11, the prime factors. So the denominators are divisible by, meaning 66 is divisible by 2, 3 and 11. Is any number in the numerator divisible by 2, 3 or 11? 181 is not divisible. 7 leave 7, it's a prime number. So 181 now. Is it divisible by 2? No. Is it
No.
divisible by 3? No, because 1 plus 8, 9 plus 1, 10. So it's not divisible by 3. Is it divisible by 11? There is a test of divisibility for 11, or you can use this one. 11 ones are 11. What remains? 7 remains. 1 comes down, so it's not divisible. So that means you just have to multiply and give the answer. That's the simplest form. Because the denominator, in the denominator, 66 is divisible by 2, 3 and 11. See, how did I make out that? Because 66 is 233 times 3 11s are and 11 ones are. So 66 is 2 into 3 into 11. But there is no number in the numerator which is divisible by 2, 3 or 11. So you just have to multiply 181 into 7 into 7. 156,
1,367.
Yeah, 1267 divided by 66 into 4. 264. And then write this as a mixed fraction. You can do that. But this is a mixed fraction, so many meters. That is the length of the room. Please write it as a mixed fraction. That will be the length of the room. All right, children?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes,
Take a
ma'am.
picture. Yeah, take a picture. Yeah. Yeah. Yes, children. So here you can see some assertion statement. You can see some assertion reasoning type questions. I think I've collected 5 for you. Yeah. So these are assertion reasoning type questions. So you have a statement against assertion. Against assertion, you have a statement. And below that, you have another statement which is called the reason. Okay, so these are the options given to you. Against assertion, you have a statement. Against reason also, you have another statement. Now you'll have to read both these assertion and reasoning statements.
Ma'am, what is
And
assertion, ma'am?
assertion is just a statement. It may or may not be a fact. Assertion is just a statement. It's like an opinion kind of.
Yes, ma'am.
Assertion is a kind of an opinion, which it's not a fact. It may not be a fact. It may or may not be a fact. It's just an opinion. And reason is a reason statement. Now, you have to read the assertion and reason statements and say which is true. If A, B, C, or D is true. I'll do the first one for you. You can try the others. So the assertion statement says I told you assertion statement need not be a fact. It's just an opinion. Multiplicative inverse of a non-zero rational number. So forget zero. Okay, non-zero rational number. Multiplicative inverse of a non-zero rational number is, number A by B is B by A. Is that correct?
Yes.
Yes, ma'am.
Yeah, ma'am.
It's true. Yeah, this is true. Okay. Now read the next one. A by B into B by A is the same as B by A into A by B is equal to 1.
Yes, ma'am.
That's also true, ma'am.
This is true. But
Yeah.
now what you have to check is the reason and explanation for the assertion statement. See, after identifying if the statements are true, see, step 1 is read the assertion statement, write true or false against it. If that statement is a fact or not a fact. If it's a fact, true. If it is not a fact, false. If I say in the assertion statement, if I say area of a rectangle is equal to 2 into L plus B. Okay. Assertion I say area of a rectangle is equal to 2 into L plus B. Is it true or false?
True.
Area of a rectangle is equal to 2 into L
It's
plus
wrong,
B.
ma'am. Only perimeter is 2 into L plus B.
Perimeter is 2 into L plus
Yeah.
B. Area is not 2 into
Ma'am,
L plus
but
B.
we can't say both
Area
is
is just
false,
L
ma'am.
into B.
No, I didn't say both. No, I said only one. I said if I say if in the assertion statement, if I say area of area of rectangle is equal to 2 into L plus B. This is the only thing I said.
Okay.
Then is this true or false?
It's false.
It's false, ma'am.
False. Yeah. So that's what it is. You will have to read the statement and first write if they are true or false. So multiplicative inverse of a non-zero. Okay, this one is true. Now this one, A by B into B by A, B by A into A by B is equal to 1. Is this true or false?
True, ma'am.
True.
True, ma'am.
Now
It's
read
true,
this.
ma'am.
Yeah. Now, what you will have to do is see A, B, C, D, and which of the options is not possible? This is not possible, right? A is true, but R is false. No. A is false, but R is true. This also is not possible. Yes or no? Because both are true.
Yes, ma'am.
Now, one of this is the correct option. Which is it? Both A and R, that is both assertion and reasoning. Both assertion and reason are true. And R is the correct explanation of the assertion statement. Is that correct? Or both A and R are true and R is not a correct explanation of A. What is explained in R? What is explained in R?
The commutative law of multiplication.
No, not commutative.
The reason is being explained.
Ma'am, I think option A, ma'am.
No, 1 minute. Am I clear so far? Am I
Yes,
telling
ma'am.
you what? Okay, so now see, C and D cannot be the correct options. So now it's between A and B.
Option A.
It's between A and B.
Option A.
Now, yeah, that's what it is. You'll have to decide if the reason is the correct explanation of the assertion or not. Children, give me a minute. There's again somebody at the door. I'll just come back. Yeah, thank you, children. Yes, children. Yeah.
Ma'am, the correct, sorry ma'am, the option is A.
A.
Yes,
All of you?
Correct answer A.
Yes, ma'am.
A. Exactly. A is the correct option because it's the same situation. The assertion talks about the same situation. Assertion assertion talks about the same situation. What is spoken about in the assertion statement? It's about the multiplicative inverse. And how do you identify the multiplicative inverse? So why do you say that B by A is the multiplicative inverse of A by B? Because its product is 1. Exactly that is explained here. Exactly that is explained here. A by B into B by A. Supposing this is given in the assertion statement and the reason statement, supposing this is given A by B plus minus A by B is equal to minus A by B plus A by B is equal to 0. What is explained in the reason? Additive inverse is explained,
Additive
correct?
identity.
Additive inverse.
Okay.
Additive inverse, identity is different. Additive inverse is explained. Then it is wrong. Then you will say that the assertion is true, but the reason is false. The meaning, sorry, assertion is true. The reason is also true. So sorry, I went wrong in saying that. Assertion is true. Reason is also true. That means both assertion and reason are true, but reason is not the correct explanation of the assertion. I'm saying, supposing this was given. Assertion statement is the same, what you see on the screen. But for reason, instead of what is given, if this was given A by B plus minus A by B is equal to minus A by B plus A by B is equal to 0. Supposing this was given. What is explained there? The additive inverse is explained there. Additive inverse is explained there. But in the assertion statement, what is explained? The multiplicative inverse. So both are correct. Assertion is correct. Reason is also correct. So here you should say both assertion and reason are true, but reason is not the correct explanation of the assertion statement. Am I reaching you, children?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Yeah.
Yeah,
So
ma'am.
here, yeah. So here, both are true. Both the statements are true. And the reason is the correct explanation of the assumption. Because it's exactly what in the reason, what you see in the reason is exactly what is here. So the reason is the correct explanation of the assumption. So A, all of you are right. Take a picture, children. So these see, when now this is too much of writing, I leave it to you. You can write it in your notebook. Again, if you feel, like it's too much of writing, maybe you can save this somewhere and go through, like when you need to practice, you can just go through, but that's difficult. Only if it's in a notebook, it should be in one particular place. All your learning material should be in one particular place. If you have some in the notebook, some in, on your tablet, some on the laptop, mobile phone, pictures on the mobile phone, you can't remember. You must have everything in one place. Okay. Assertion. A rational number between 2 by 3 and 3 by 4 is, sorry, this is 7 by 24. 17 by 24, sorry. 17 by 24. Now you'll ask me, how do we know? How do I know if 17 by 24 is between 2 by 3 and 3 by 4? Do you all have that question? Shall I explain that?
Ma'am, I know how.
Yeah, tell me.
Ma'am, we find here the LCM is not used. So we have to make the denominators equal.
Very good. You must bring 2 by 3 to the same denominator, 24. So into, correct. And 3 by 4 also to the denominator 24. So what will it be? Why, Anantika?
Yes, ma'am, the assertion is true.
Yes, ma'am.
Okay.
Because 2
Six,
by 8
so-
is equal to
Yeah,
6.
So
so
now you
it's
can
between.
see. Yeah, so you can see 17 by 24 is between 16 by 24 and 18 by
Yeah.
24. Very good. So that's right. So you will have to bring all the fractions to the same denominator. So you can see the largest number in the denominator is 24. So you'll have to bring 3 and 4 to 24. Or you should bring all the denominators to the same number, which is the LCM. Okay, I'm sure you all understand this. So 2 by 3, write an equivalent fraction. Write a fraction equivalent to 2 by 3 with denominator 24. And again, write a fraction equivalent to 3 by 4 with denominator 24. So now you can see between 16 by 24 and 18 by 24, yeah, we have 17 by 24. So this one is true. The first one, that is the assertion statement, is true. This is true. And what is the reason? Between any two rational numbers A and B, there will be another rational number, half of A plus B. True. Correct. Whenever, see, now you take 8 and 10, okay? 8 and 10. What is 8 plus 10 by 2? 18 by 2, 9. And 9 is between 8 and 10, right? Whenever you find, when you have two numbers A and B, if you divide their sum by 2, that will always be between A and B. Always. You can check with any number, any two numbers. Between any two rational numbers, A and B, there will be another rational number, half of A plus B is true.
The answer is A, ma'am.
Yeah. So both assertion and reason are true. And in the reason, the same situation is explained. Like in assertion also, we have a number between two rational numbers. So here also they're talking about the same situation, that the rational number between two numbers is A plus B by 2, half of A plus B. Okay. So if you're asked to find, supposing you're, see, there are infinitely many. Okay, let me, oh, it's 9:40. 5 more minutes, children. I'll wind up the session. I think I shouldn't ask you these questions now, then it will take a longer time. We'll see them in the next class. Let me go ahead with this. Is this fine, children? Let me talk about numbers between two rational numbers in the next session. Is this fine? Understood this one, all of you?
Yes, ma'am.
Yeah, ma'am.
Yeah, take a picture. Yeah,
Taken, ma'am.
yeah. Root 2 by 3. Square root of 2 by 3 is a rational number. Is that true?
Excuse me, ma'am, can you please show the question too? I didn't take the screenshot.
Sure. Yeah.
Thank you, ma'am. Yes, ma'am.
Yeah. Is the assertion statement true? Square root of 2 by 3 is a rational number. What's a rational number? Integer by integer is a rational number, right?
Yeah.
Yeah, so it's true. Correct?
Yes.
Yes, ma'am.
P by Q form is a rational number, right?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So is the assertion statement correct?
Option B, ma'am.
No, darling. Is the assertion statement correct or wrong?
Yes,
Yes,
ma'am. It's correct, ma'am.
Yes, ma'am, it's correct.
But all of you are wrong. All of you are wrong. What is a rational number? Anything of the form P by Q, where
Yeah.
P is an integer, Q is also an integer. 3 is an integer, but is root 2 an integer? What is an integer? It should be a natural number or the negative of a natural number or 0. Is root 2 a natural number? No.
No.
Is it the negative of a natural number? No. It's
No.
not 0. Then it's not an integer at all. Integers are these numbers, which you can see on the number line, like these are integers. It goes on. You don't know the smallest integer, nor do you know the largest integer. You can see here, it goes on. It extends indefinitely on both the sides. So natural numbers, their negatives, including 0, form the collection of integers. Now, root 2 is not one among this collection. So since root 2 is not an integer, this one looks like p by q, but it is not p by q in the actual sense. It's not this one is not an integer. This is an integer. So root 2 by 3 is not a rational number. So this is false. Then number which is of the form p by q. P and q belongs to. This is belongs to symbol. This symbol stands for or is read as belongs to. P and q belong to z. Okay, so P and Q belong to Z. Z meaning integers. Z meaning integers. I told you in the last class, no? I, Z represent integers, but there should be a capital Z, children. Capital Z. P and Q belong to integers. Belong to or belongs to. Okay, belong to or belongs to. So here P and Q belong to integers. Q not equal to 0 is called a rational number. So this one is true, but this is false. So assertion is false, but yeah, reason is true. 1 minute, take a screenshot now. This is true. So this one. Because this is not an integer. This one is not an integer. This one is an integer. Fine, children?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. This one more, children. We'll wind up. Just one more we have. Yeah. The additive inverse of a plus 1 by a for a 5. So when a is 5, okay, so a is 5. So 5 plus 1 by 5. What is 5 plus 1 by 5? 6 by 5. So the additive inverse of 6 by 5 is minus 6 by 5. Is that true?
Yes, ma'am.
Now see here, the value of a is given, okay? So here, instead of a, use 5. Use 5. The additive inverse of
No, ma'am. No.
5 plus 1 is 6. 6 by 5. Is this correct? True or false?
False. False.
Why? Why, children?
Oh, ma'am, the additive inverse, I thought multiplicative inverse.
The additive inverse of a plus 1 by a is 5. So use 5 here. Use 5 here.
Ma'am, it's
So
true.
what's the number? What's the number?
It's
6
true.
by 5 is the number. And its additive inverse is minus 6 by 5. This is true. The additive inverse of any non-zero rational number is its reciprocal. True or false?
True.
The multiplicative inverse is the reciprocal. Additive inverse is not the reciprocal. Additive inverse is the negative of the rational number. Additive inverse is the negative of the rational number. Multiplicative inverse is the reciprocal of the rational number. So here it's given that the additive inverse is the reciprocal. No, multiplicative inverse is the reciprocal. See, for additive inverse, did you take the reciprocal in assertion? For additive inverse, did you take the reciprocal? No, you just change the sign. So additive, the correct statement is the additive inverse of any rational number is its negative. Is its negative, not reciprocal. So this is false. So assertion is true. Reason is false. Take a screenshot, children. This one is A. 1 minute. So you should use 5 here. You should use 5 here. This one is true. This one is false. And A true, R false. Yeah, now you can take a picture.
Taken, ma'am.
Yeah. But I'm not sure if the screenshot will capture the annotations. I don't know.
Ma'am, it is.
Okay, fine. Yeah. All right. Yes. Assertion. So this is the absolute value. If x is equal to minus 2 by 7, then the absolute value of minus x is minus 2 by 7. We need to understand this. 1 minute. How do you write the absolute value of minus x? X is minus 2 by 7. So minus x meaning you should put a minus sign here, correct? No, listen to me carefully, children. I don't want the answer. I want you to understand. So see here, x is minus 2 by 7. So how will you express the absolute value of minus x? So see here, will be absolute value of x is minus 2 by 7. But minus x, so you should put a minus sign here. Is this fine? So what is it actually? It is minus into minus plus 2 by 7, absolute value of 2 by 7. What is the answer? It's 2 by 7 only. Because absolute value, you ignore the sign. The absolute value is always positive. You take only the numerical value. It's always positive. The absolute value of minus 5 is 5. The absolute value of 5 is also 5. Whether it is positive or negative, it's always positive. You just take the numerical value. So how do we write the absolute value of minus x? Put the minus sign. Write x here. What is x? Minus 2 by 7. Now this is nothing but absolute value of minus into minus is plus 2 by 7. Now the absolute value of 2 by 7, it's 2 by 7 only. It can't become negative because it's positive here. It will not be negative here. So always positive. So is the assertion true? Is the assertion true, children?
Yes, ma'am. No, sorry, ma'am. No, ma'am. The reason is wrong.
The absolute value of any rational number is always non-negative.
True, ma'am.
True.
Sorry, ma'am. Both of them are true.
No, ma'am.
The answer is A, ma'am.
Ma'am, isn't the answer D?
Yeah, A is false, right? A is false. That means, see, you people are not listening to me. You already process, the answer in your mind, and you're just waiting to share your answer with me. A is false. Well, I repeated that 2 times. I'm not doing it again. A is false, children. Now the reason, that means assertion is false because the absolute value cannot be negative. You don't have to work so much. Absolute value cannot be negative. So straight away it's false. That's all. Now reason is the absolute value of any rational number is always non-negative. Correct. It's not negative. So this is true.
Option D.
Yeah.
So
A is
assertion
false,
is
but R is
false.
true.
Yeah. Got it, children? So there's
Yes.
a part of your syllabus. Assertion, reason type questions is a part of your syllabus. Assertion, reason type questions is a part of your syllabus. You also have something called value-based questions or case study-based questions. We'll see them in the next class based on rational numbers. Value-based questions, also called case study-based questions. So along with MCQs, your question paper will have questions of these categories, multiple choice questions, also called objective type questions. Then you have short answer type questions, long answer type questions, assertion reason type questions, and value based questions or case study based questions. And you also need to know a few higher order thinking skills, HOTS, higher order thinking skills questions. So all that will be, all these, all these type of questions will be covered whenever I do a chapter. All such questions will be covered in the chapter. We don't do it like separately before the exam or separately during revision. It's not like that. When I complete a chapter, it's completed in full. There is nothing remaining in that chapter. It's like that. Okay. I'm sorry, but I'm holding you. I know. I hope your parents are not upset with me. I just need to share something else with you. Now, children, I'll share your credentials. Okay, I have not still generated them. I'll share your credentials. Now, in the browser, can you see my Google browser?
Yes, ma'am.
Yes, ma'am.
Yeah.
Yes,
So
ma'am.
there you'll have to just type. I'll share the details on WhatsApp, but I'll just show you what you're going to do. Atharv dot test press.
Ma'am, actually, I've given for me.
Anantika, is it? Okay, fine. Dot in. Okay. I think then for, okay, fine. This is what you need to type in the browser. And when you say enter, it'll take you to, okay, I have not logged out. So 1 minute. Okay, so when you type atharv.testpress.in, it'll bring you to a page like this, the login page. So this is where you will be taking your online exams. This is where you will be taking your online exams. So you need to type that URL. You need to type that URL in the browser, and that will bring you to this page. And here I'll share your credentials. I'll give you your username and password. So I'm just typing mine here. I'm just typing mine here. Okay, and say login. Just say login. Just say login. Put your username and password and simply say login. When you log in, you will not see so many tabs. You will find only the exams, and then you will have this documents and analytics. You will have only 3 tabs. So from the admin's end, I can see all this. But students will see only 3 tabs. See here, I can see exams, I can see questions, then I can see documents, and I can see memberships, I can see posts. So I can see so many here. But you will find only exams, documents, and analytics. Now in exams, in the exams tab, can you see 3 different tabs here, running, upcoming, and completed? Can you see them here?
Yeah.
Exams, you can see running, upcoming, and completed. So if you see some exams in running, that means those exams are available and you have to take them up. Running, if you find exams in the running tab, under the running tab, then that means those exams are available now for you and you can take them now or anytime in the future. They are available for you. Upcoming meaning I have scheduled some exams for you which are not available now. So maybe for April 5th, I have scheduled an exam for you for April 5th. So you can see that in the upcoming tab. When you go to upcoming, you will see the exam schedule there, but you cannot take it up now because it's scheduled for a later date. Then when you move on to the next one, completed, you will see all the exams that you have completed in the past. You can see all the exams that you have completed in the past. So now, I think now or maybe by tomorrow, I'll enable an exam for you. So you can see it in running. You can see it in running. All right.
Okay, ma'am.
Yeah, so that means you'll have to take up that exam and you can take it anytime because I don't set an end time for the exam. I don't set an end time for the exams. You can take it up anytime before the next class. The exam will be available. But once you start the exam, supposing the exam is scheduled for 45 minutes, once you start the exam will automatically end in 45 minutes. See, supposing I schedule an exam for you now and it's you can see it in the running tab. Okay. You can take it.
See the marks what we have scored.
Yeah, you can see everything. You can see all the details. I think that instead of me telling, you can explore it yourself. And I'll tell you, maybe, and those details, I can share it in the next class for you. It's time also now. That's the reason. So you can see everything. You can see the correct answer. You can see your answers, the correct answers, your marks and your percentage and everything. So yeah, that's what I want to make this part clear, So you can take up the exam now, tomorrow, day after, anytime you can take up before the next class. But once you start the exam will end in 45 minutes. Remember that. All right, children. But you can take it up anytime. So you have time tomorrow, you can do it tomorrow or day after or the day after that. But once you start the exam will automatically end in the given time, 45 minutes or 60 minutes or 90 minutes, whatever. All right, children. Aishwarya, this being your first class, girls, turn on your videos. All of you, Sai Smriti, Aishwarya, Anantika, Shreya.
Ma'am, actually I am having 6% charge, so the video is off, so I can't
No
turn it
problem.
on.
Okay. Aishwarya and Anantika. Aishwarya.
Yes, ma'am. Can you see me? Hello, ma'am. Can you see me?
No, darling. No, I cannot. Yeah. Okay. So Aishwarya, you're connected from Bangalore, right?
Yes, ma'am.
Okay. Fine. You just finished your exams the day before yesterday, correct?
Yes, ma'am.
Okay, fine. So how did it go? Your exams? 7th
Yes,
standard
ma'am.
exams? Okay. And which school are you into now?
I'm going to Cambridge, TCIS.
Okay, fine. What have you filled in the Google form? The new school or the old school? No problem. Fine. I'll check it out myself. Fine.
My mom has filled the present school.
Old school.
New school.
No, I'm the
Okay.
old school, the school I was in.
Old school. Okay. No problem. All right. Fine, girls. That's it for today's session. Thank you so much. You may all leave the call. Thank you.
Thank you.
Thank you, ma'am.
Thank you. Good night, children. Thank you.
Good night, ma'am.
Good night.